So you can watch it as it happens? Everyone's staring at their phone?
No, actually, I was thinking that after it happens.
Okay, well, let's go ahead and get started then. Thank you for coming out tonight to the Houston Perl Mongers. How many people are actually from Houston? Most everyone? No, just like you didn't drive from like Fort Worth or something, or I mean, some people have done that before. I'm always impressed that people would come that far for free pizza. Okay, I've been here at cPanel this week teaching a class, and I'll be here next week teaching a class. And when I come down here, I like to give some sort of talk about something. Lately, I have been working on the second edition to Mastering Perl, this is the first edition of that book, and as soon as I finish this up, which hopefully is this week, I just have to make the corrections for the tech reviewers. I can pass that off, and it'll be available sometime next year. But part of this book was a chapter called Advanced Regular Expressions. And as I left that for last because I knew that chapter was going to be hard. A lot of the stuff that was in that chapter before got moved down into intermediate Perl, and some of it got moved into learning Perl. And so now when I took out all that stuff from Mastering Perl, second edition, there was very little left, so I had to find something else. Well, fortunately, Randall Schwartz provided me just the thing to fill that gap. Before I get that far, if you want to look at the Mastering Perl that I'm working on right now, the second edition, you can do that. You can read it for free through O'Reilly's Atlas system. I have a fancy URL up here, but then the short one too, so you don't have to type in all that stuff and remember that huge number. The stuff we're talking about is actually in Chapter 2, and it's online and you can read it for free for a while at least. But Randall created this great thing for me to fill this hole in Chapter 2. He created this JSON parser in a single Perl regex, and he used all of these special regular expression features that most people probably don't even know exist. Now, the trick with his is that he's working on this particular client problem where the JSON is minimized and all shows up on one line. So his regex doesn't handle stuff going all over the place. He only wrote it to handle ASCII only because that was the requirements of his particular task. And his thing fails very quickly. If it finds a problem, it doesn't take forever to come back and say, I found a problem. But even with those caveats, it's still a pretty impressive regex. Now, I'm going to have to split the thing up across a couple of slides. Here's the first part of it. Okay, everyone got that part? And then the next part, and the next part. Now, I'm going to talk about the features that are in here without going through this particular regular expression, because this one is really tricky. But I want to go through each of the features that this thing has. So here's how he calls it. He has this thing called from JSON. He takes in something and puts it in $_. He localizes this variable $R, which we'll see in a moment. And then he matches against that. Now the curious thing is that after he's done with that, when he comes back, the target string that he had matched against is now the data structure. So in that regex, he actually replaced the target string. He did a substitution with the data structure, whatever represents the JSON, the array of hashes or hashes of hashes or whatever it is. So let's look at some of this. Now, it doesn't show up so well on with this projector, but some of these parts are actually in red. So what I want you to look at are some of these open paren question mark sequences, and they have a single curly brace after it. This is a feature in Perl regular expressions that allows you to run some code right there in the regular expression. Now, you can do anything you want, but it's even fancier if you do some of the stuff that affect what the regular expression is doing. And you'll notice that I've highlighted quite a bit of these. He has these all over. Anytime he's doing anything, he is somehow running some code to process something. Now the next bit is that he's defining a grammar here. So these parts marked in red, they are defining various ways to tokenize something, to break this part up into what it is. So he has a way to, up there it says define, that starts this little grammar. And then he has a thing that's for object, for a key value pair, for an array, and so on, all the way down for all the things that you can have in JSON. Now when he wants to call one of these things, he uses one of these guys, the open paren, then the question mark, and the ampersand with the name of that particular piece after it, which means we have some recursion going on here. Because inside these things, you might have an object which is calling this KV thing, which might call some other stuff, and pretty soon it's wrapping around on itself. That's pretty cool. This means we can match balance things And then next, we've got this special variable $$R. And I'll see how that works as we go on. But he's building up the data structure and keeping track of his parse state by continually putting stuff into there and looking at stuff that's already in there. And that's why he keeps running all of these, the open paren question mark single curly brace things all over the place. So he's written a little program in Perl regular expressions. And there are people you know in Perl who would love to write their entire program as one regular expression, and now you sort of can. So here's all the things he's doing. He's using the grammars, that's the define bits. He's recursing into things, so he's calling some of these tokens that sometimes call into other tokens that might have already called them. He keeps doing that. We're running code during the regex. He's building up a data structure as he runs that code because he's putting stuff into $$R, looking at what it was before he got there, modifying it, and putting new stuff into it so that the next time he looks at it, it's a little bit different. And then at the end, this is really cool. In these single curly brace structures, $_ is the target string. So at the end, when he finishes off this regex, he takes whatever he has in this particular anonymous array reference he has in $$R and assigns it to $_, meaning after you do the match, the thing that you have in your string that you bound to is now the data structure. That's wicked cool. I don't know if anyone would want to expect that or maintain that, but that's really interesting. So here's what I want to do. I want to start off with this basic thing. I'm going to have some string, and it has a quote in it. So it says, Amelia said, I am a camel. For those of you who don't know, Amelia is the name of the programming Perl camel. So she says, I am a camel. Now, we can easily write a regular expression to pull out that particular quote. We only have one in there, and we know we start with a double quote, and then we go to the other double quote. But we're going to get much more fancy with this. So maybe I'll write something like this. I will write, I want to match something that is either a single quote or a double quote, and then I'm going to have this named capture here instead. I'll just match all the stuff non-greedily up to the next thing that is a single quote or a double quote. Okay? And that's fine. That works. I'm not going to show you all the output for these things as we go along. Just trust me that it works. You know, like every other programmer tells you, trust me, it works. Some of these probably do work. And then, since I have this in a name capture, that's going to show up in the %+ variable. That's the thing that remembers those names for us, and I can just look in the key for sed to find out what I matched in this parentheses group. That's fine. That works. But let's get a little bit more fancy. Instead of doing repeating the same thing, I could just put a back reference here. So I'll remember something in here. This is my $1. And then when I want to match something else, I say I'll just match the $1 again. Okay? So if I match a double quote here, I have to match a double quote here. If I match a single quote here, I have to match the same thing. But that's not so interesting. That's not too fancy. So we're going to go a step back, and I'm going to put this. I'm going to put $1. Now this is going back to basically what I had before. This is a reference back into the pattern. When you see the open paren, the question mark, and then a digit there, that means go back to that first capture group, which is this guy, and run that capture group again as an independent subpattern within this pattern. And independent means it gets its own set of memory variables and captures and all that sort of stuff, and it will match whatever it matches, and then advance the match counter how it needs to. And we're going to see how that can help us out later on. That's really nifty. Right there, nothing too fancy, though. I'm just showing you how that works just in that very simple case. Oops, did I? Oh, and notice this is going to match this thing. Amelia said, single quote, I am a camel, and then I end with a double quote. Because I'm saying just run this thing again as an independent pattern. And this says, oh, I can match either one of those. So this is slightly broken, but we're going to get better. Okay, let's change it to this. He said, Amelia said, I am a camel. Now we have single quotes, and in the middle of it we have some double quotes. Now it doesn't matter that they're different. I could have made them be the same sort of quote, and this would still work. Well, actually, this is not going to work for the same reason I just told you on the previous slide. The next one will. If I match this, I match a single quote or double quote, so I'm going to end up with the single quote there. Then some stuff non-greedily up to run that pattern again Well, it can match a single quote or a double quote, so it's going to match up to there. So we'll get in this little quote just Amelia said. So we don't want that. What we can do is this. Now this is a little bit more complicated. Okay. I'm going to move the said name capture up to here. Now there's some crazy stuff going on with this, but it will illustrate that stuff I was talking about as an independent pattern. I'm going to have another name capture here to talk about the particular quote that I matched, the single quote or the double quote. Now down here, I'm going to have this back reference to that named capture. So whatever I matched in this thing called quote, it's going to capture again. Okay? So it has to be the same thing now. But now in between that, I'm going to match things that aren't a single quote or a double quote. Now I'm using this plus plus. You might not have used that before, but that's a non-backtracking one or more thing. We don't want too much backtracking in this problem because we could go crazy. But if I can't match that, what I'm going to do is come in here and match said again. Now there's some problems with this. Well, I'll talk about that in a moment. And that independent subpattern again. Okay? Now this will work. What I'll get out in said are the two quotes. Amelia said, I am a camel, and then I am a camel. But I had to do this trick where I put this name capture in here again. I wouldn't get that out from just running the first capture group again, which is this whole thing here. Because this reference back to that first capture group is an independent subpattern. It has its own version of all these variables, just as if we had localized them. So when I come back from that, when that subpattern finishes, it forgets everything it remembered, and I just get the outermost thing I said. Well, that's no good. So now we're starting to think about, once we get into this stuff, how are we going to start remembering all that? And you saw some of the stuff Randall was doing. So I'm going to do this. I'm going to change this around a little bit. Instead of having that name capture again, I'm going to put this back reference here. Well, it's not back reference, it's independent subpattern. But instead of a digit, it's capital R. And when I say capital R, it refers to the entire pattern. So everything in here. So it goes back to whatever the start of the pattern was. It doesn't have to be a capture group. So I'm going to do this, find a quote, find some stuff that's not a quote. If I run into another quote, I am going to redo the entire pattern from the start, from where I was starting. And when I finish that, I'll come back out and finish this one. And then, if I run into another one in there, I will just keep doing that. Okay? Now at the end here, look what I have. I have at the end of this pattern, I have a little bit of code that says inside the regex, this is what I found for the name capture. So every level I get to, at the end of that level, I will print this out before I finish this part of the pattern. So from inside the regex, I can actually print out the part that I'm working on. This is the part that I just matched. I couldn't remember that before because this was always independent. Okay? That's pretty nifty, but it's going to get better. Okay? Let's use some of these grammar stuff we have going on. And once we start doing this, the regexes get fun again, because you can now do all sorts of fancy things. I'm going to have this define group up here. I start this off, I say question mark, and then in parens I say define. And then I have things that look like name captures, but these are really just going to create these things that are subpatterns that I can use later on. Okay? So I'm not really changing too much. I'm just creating this little grammar here. And where I had the quotes before, I just call back to quote. So it's going to go back and do whatever that pattern was. And then I have my not quote stuff. Okay? Otherwise, it's the same stuff that we just saw. But now I'm just making a part of it a little more abstract. But I think I can get even better there. Oh, wait. I'm not going to get better just yet. I still have this part at the end that looks in %+. So that's going to look for my name captures. But I don't want to do that anymore. I want to get rid of this thing because I don't want to have to keep looking in these variables that are going away. So this is how I'm going to do that now. I'm going to define at the top of this other array at matches. Same scope as the regular expression, but it's not defined inside the regular expression. And at the end of each of these subpatterns that I run, I'm going to push onto that the value of $$n. This is a special regex variable that is the result of the last capture group. The previous capture group, I should say. So look what the previous capture group is. It's this thing. There's the open paren, there's the closed paren. So when I get done with that, the thing I just matched, the quote, is the thing in $$n. I push that onto @matches. Then when I'm done with this entire regex, I can look in @matches, and I can see all the quotes that I matched, because these things are all still disappearing when I run these independent subpatterns. Okay. This trick actually doesn't show up in Randall's code, but it's still pretty nifty. But we're going to modify this a little bit to do some of the same stuff he was doing. Okay, so let's get a little bit more fancy with this. So I have my stuff. I'd change it now to quote mark and not quote mark up there. So I can call this whole thing quote, the thing that I'm matching. So now in here, I'll just refer to this by its name instead of the $$R, or excuse me, the open paren $R that I had before. Okay. Now, this is still all in a define. So there's a quote mark, a not quote mark, and a quote. And then to run that whole thing, I just execute the quote thing, this guy, and it goes through and does the same thing that I saw before. So now we have this broken out where all these things have names. And looks like there's hardly any sort of regular expression stuff in there, it seems. It's looking a lot more like a grammar. Okay. I still have my stuff at the end of there that I pushed $N on the matches, but we'll get a little bit more fancy. That's it for the grammar portion of this. Okay. Now what I'm going to do is I'm going to change this bit here where I was pushing onto @matches. I am going to use a special variable $R. Okay. Now, before this, I've initialized this thing to be an anonymous array. I just couldn't fit it on the slide. I already have quite a bit of stuff there. So what happens with $R is the result of the last bit of code that I ran inside one of these question mark curly brace constructs. So whatever the last evaluated expression of one of these things are goes into $R when it's done. So the next time I get to one of these things, it's the result of the last one I did. And this is the only one I have in there. So I'm carrying around the value of this thing in between independent calls to this. So this is where Randall is building up his data structure. Every time he got to run one of these, he was putting more stuff in here. And he was unrolling the stuff that was already in there to work it into the data structure he was building. So what I'm going to do is I'm going to make an anonymous array. There's my square braces. And I'm going to expand this as just a regular array to get its elements out as a list. So now I have this flat list, and I just have this $N on the end. That's sort of like doing a push, just putting an element on the end. Not the most efficient way to do this, but it's working out. Now, this whole thing is in this anonymous array. This is the last evaluated expression. So this thing becomes the result of this execution of this curly brace construct. And this is a value that we'll get the next time we come around and see this again. It'll just have the latest match on it. And we'll just keep doing that. Every time we see another match, it gets pushed on this thing so that we make this new anonymous array, and we come back and we keep doing that. Now at the end of this, after I've run this quote thing, and it's done all of this, and it's gone through all of this, and put all these $Ns onto here, I'll just take my $R, dereference that as an array, and assign it to @matches. So now that variable I had outside of the scope of the regular expression now has all the matches, and I don't have to do anything fancy with that. It took me a while to figure out how this actually worked, though, because you can't just dereference this like you would expect other Perl scalars, saying $$R. If you actually try that with dparse, you see that it parses it as $$ exclusive or bare word R. I think that's probably a bug, but probably not one worth fixing. And so it took me most of the night to check to actually find out what is it actually trying to do there. And so you have to have the curly braces there. Okay. Do we have... That can't be the end. I think that is the end. Huh. Okay. So let's go back and look. And so I'm not going to go through the whole thing, because even I don't completely understand everything he was trying to do here. But he starts off, he says this value, and then he has the same sort of thing that I had, except he's going to assign to $_. That's going to be the part that puts the data structure into the target string. And he's pulling it out of $$R, which is always the result of the last thing he just ran. So he's building up the data structure in index 1 here. Now here's his define. Now that just goes on and makes a thing for object, for KV, and so on. But let's look at one of the things that is simple. Oh, here's value. Value is a nice one. The other ones get kind of complicated because they have to do quite a bit. So a value will have optional white space at the beginning or the end, and then it can be either a string, a number, an object, or an array, or it can be true, false, or null. And JSON has various ways of representing those, so those are special values. So when it finds a value, it just goes and says, okay, I got to figure out if you're a string, and it goes and does the string thing, or if you're not one of those, I'll do a number, or so on. So let's go look at, let's see, where is number? So here's number. I can start off with an optional minus sign, then I can have 0, or I can have 1 to 9 and some digits. Then there can be some decimal places or exponential notation. Now when I'm done with this, I'm going to take the previous result of $$R and make that the first element, and then I'm going to say, take the thing that I just got, which is going to be in $$N, and eval it. Now he's doing that to turn this string into a number. So now it's a number. And that's what we get back. Okay? So here's string. He's going to do the same sort of thing. Now, we're fortunate here in that JSON makes you use double quotes. So it just says, we're not going to have this confusion with all the quotes. We'll just use double quotes. So a string is going to start with a double quote, and then there's going to be some stuff. Stuff that is not an escape or a double quote, and then let's see what we can have. We can have some escape stuff, or we can have some escape stuff with a U for the wide characters in it. And then he's going to do the same sort of thing. I'm going to take the current value of $$R, put it in this anonymous array, take what I found, and eval that. Now I get the Perl string.
So that's commented out
because he only supports ASCII, yes. And so I know he was thinking about that, but then he probably said, if I have that, I'd have to do some extra work in here to turn that into the right Unicode character. So I know he's thinking about that. He said as much on Perl Monks, it's just his client doesn't need it right away. And so that's what, oops, let me go the other way. Nope. And then that's the same sort of thing that's happening in these things, in the object and in the array and in the KV stuff. Now it seems very simple when you sort of work it out or have someone stand in front of you and explain it, but this took me maybe 3 days to sort of wrap my head around, to finally find out, what were you thinking, Randall? And you got to remember that I used to work with Randall for a long, long time, so I'm sort of used to how he thinks.
So does from JSON end up as a hash graph?
So from JSON is going to end up as whatever the top level data type is for JSON. I think you can have arrays as the top. So it should either be, and you can't have just a string as a JSON, valid JSON, can you? Like just have true, and then just you're done. I don't know. I don't know that much about JSON to know what's actually valid. It's most likely going to end up as a hash ref because that's probably how most people pass that stuff around. That's pretty impressive. There's a whole lot going on there, and I had a lot of fun figuring this thing out. And he doesn't explain it in Perl Monks. He just says, here it is. Doesn't everyone do this all the time? Any other questions on this? It does look like Lisp. But if you look at Mark Jason's book, Higher Order Perl, he says Perl is Lisp. It fulfills 6 of the 7 things that Peter Norvig says you have to fulfill to be Lisp.
I don't think there are enough parentheses. I can see some white space that doesn't have.
We can put some more parentheses in it. We just make more captures.
So how does this benchmark against JSON XS?
I don't have data for that. I should try this for that, but I know the reason he wrote this is because the other alternatives weren't fast enough for his client. Now this doesn't handle everything, right? Exactly, but he obviously didn't need that. I don't know the particular problem he was trying to solve, and I haven't benchmarked it myself. And I don't know how I think what they were trying to do is somehow fail faster. Like he kept talking about that. I need this to fail as soon as possible, not go through the entire thing and create this big deal. But again, that's internal client stuff that he wasn't able to divulge.
So I remember that when Lehman talked about the parser, he says you only have to look back like 2 or 3 characters ever when you're walking through the output, which is why it's so why it can be parsed so efficiently.
Oh, okay. Yeah, I mean, I haven't ever had to write a JSON parser myself, so I mean, but I imagine so because it's a very simple format. There's only so many things that we can going on, which is like choosing the double quote. That's the only thing that you can use, and then there has to be a colon and then a thing, and then you're just and especially if you collapse all the white space, you just ignore the non-significant white space. I don't know. Any other questions about this stuff? Okay, so that's all I really wanted to say about that stuff, but I am happy to talk about anything else you might want to ask me since I'm already here. Just random slide?
Do you show us what this looks like, or do you by chance have this where you just run it? Because I'm kind of curious to see what the push looks like.
What the push looks like. Oh yeah, this. So all of these code samples come right out of Chapter 2 of Mastering Perl. I just copy and pasted them directly out of the book. I didn't. And aside from taking off the part that says user bin Perl, use 510 and all that, it's the same stuff from either of these URLs. And the book also shows you the output. So if we do it like, let's go back to 20. So we get at matches here. So the thing that's going to be in at matches, let's say we have this string. We have out, and then we have top with a double quote, and then there's a mid-level thing, which are mid on the other side, and then there's a thing in the bottom. Inside the matches, I should get top will be one of them, top of that whole thing to the end of the double quotes. And then another one will be mid all the way through the end of that mid. There's everything contained in that group. So the outer quotes hold all the inner quotes. And then the bottom one, there'll be one that says bottom, it'll just be bottom. If I could reach my laptop, I would pull that up. What's that?
So you're parsing embedded code.
Yes. And I just chose this because it was simple to think about and to see. I could also do things like parentheses and curly braces, and things like that.
So since this is nested, we should get bottom first, right? And go all the way to the inside of the
Yes, because that should be the first thing we pass on to. Oh, yeah, on this one, I'm just saying it as soon as I find it.
Yeah.
Yeah.
But it would have to get to the end before it would know where to match the.
Right, so it's got to get to
Well,
the end of bottom. So bottom comes out.
It's going to descend into this thing.
Finish going from
Yeah, but you don't know there's not more quotes after bottom without getting to the end of the line.
nah.
No, you're going to recurse.
It's going to keep recursing.
You're not going to ever finish the top one or the middle one until you finish the bottom one because you got this guy that's sucking it in like a black hole. And this one will finish. The very bottom one will finish first because it will do this. It can't do this anymore, and so it'll get here, and it will come back out and finish this bit and finish the next bit for the next level, and then come out and do this, and then come back and finish this one for the last level, and then match that last quote, and then push on again. Does that make sense? You know how this is. It's basically a depth first sort of thing. You're going to do all the stuff for the very deepest one first before you see the output for the ones above it. But if you don't like that, if you want to see them in different order, you can just use unshift.
Or reverse.
Oh yeah, or reverse later. Or if you want to see them in random order, you just put them into a hash and then. Okay, well thank you. I'm glad to stick around and we can talk about all sorts of different things. I have pizza still. I think there's plenty out there.
Plenty of